All right, guys, so any questions from homework? I think Amanda's first, and then go to Jackson. 7.4, question 1 2. Oh, yeah. I like it. So, guys, it's kind of neat. This works for sound also. So, guys, give me a second. You don't have to understand what I'm about to say. I'm going to explain the formula for this a little bit. This is number 102 in 7.4. Right? So, if you have a light bulb and it shines light, obviously the further you get away from it, the dimmer it looks, right? That makes sense. And that's because the light, if you think about it, the light goes out like this. It's got to cover, so it's the same amount of light, but it's got to cover a larger and larger area as it goes away. Same thing with sound. It falls off as the square of the distance you are away from it. So the formulas you get here, I don't know why they give it to you like this. It's kind of silly. I don't know if anybody sees what's silly about that. And you're like, oh, yeah, sure, Jeff. So one light bulb, let's see, from a 100-watt light bulb, and then from a 40-watt bulb, the intensity is this. This is the intensity of the light at a certain distance. So it's the square of the distance because it's the surface area it's got to cover. Right? Again, you don't have to understand any of that. This is just a formula. Who cares? So the first part says, find an expression for the sum of the intensities. So if you had both of these light bulbs sitting there, their intensities are going to add up. Right? So it's going to be brighter overall. So I just want to find the sum of these two. Can anybody tell me that first one? They gave it to me in a weird way. What's kind of wrong with that first one? Or what can you do with that first intensity? Now you can just do that all night. Just stare at it. What can you do? Say again? What does it become? Yeah. 8. Wow. All right. 32 divided by 4 is 8. They didn't give it to me reduced. Reduced. And so if I reduce the fraction, it's going to make LCD a lot easier to work with, right? So what's the sum of the two? And let me call that intensity 1 and intensity 2. So if I add intensity 1 to intensity 2, I get 24 over 60 squared, right? Yay! Somebody's going to tell me that, and a lot of you guys are like, yeah, that's what you get. But why can't I just add these together? They're not like denominators, not like terms. So, okay, is that cool? Is that enough, Amanda? All right, so that's part A. And part B probably just has you plug stuff in. Yeah. So once you get that figured out, then part B says if you're 5 meters away, ooh, look at them using correct scientific units. If you're 5 meters away, what would the intensity be? Is that okay? I don't know if anybody's tried number 1 or 2. So if you haven't tried it yet, these are a nice little start, a little preview. Anything else from homework? Jackson, what'd you have?
I just want to quiz.
Oh, go ahead. What you got?
B.
What'd yours say? What'd yours say?
A equals A plus 49.
Okay, yeah. So everybody on part B, 1B, everybody has something sort of like this. Let me combine the two ideas here. Sure. Nobody had that, but everybody had something that looks sort of like that.
What number is it?
1B, on the quiz. Right? You guys with me? Some of you guys had y squares. Some of you guys had one thing squared with a couple of a's or whatever. Everybody had something that looks sort of like that. Now, what's wrong with the way that is currently? What's your first goal in this?
Get everything on one side.
Get everything on one side. Make one side equal to 0, right? So a lot of guys just decided, no, I don't want to do that. You have to. Some of you guys got the answer a different way, but you only got one of the answers. You didn't get both answers. And that's why factoring is better, because then you can see both answers. If you did what I'm talking about, you know what I'm talking about. Right? If you didn't, don't worry about it. So what do I do? How do I get those over there?
Just move it.
How do you move it? Yeah, minus y squared, minus y, minus 100, minus y squared, minus y, minus 100. All that stuff cancels, so on that side I get 0. That side doesn't just disappear. It doesn't become the void. It becomes 0, right? And over here I get what? Is this 2?
3.
No. 2y squared minus 1y squared is 1y squared, right?
Yeah.
And then the y's,
Cancel.
and then I get,
Minus 100.
and then what do I do once I get it equal to 0? What do I do with the stuff on that side? Factor it, exactly, right? So some people are saying, like right here, they would say y squared equals 0 or 100 equals 0. No, that makes no sense. It's got to be factored first. I need a number times a number equal to 0 to say something.
Y equals 10
Yeah, because you can factor this as
squares.
y minus 10, y plus 10. So some of you guys did this a little different way, and you got y equals 10, but that's not the only answer. There are 2 answers. 10 and negative 10 for this example, right? You need both answers for this to be right. Cool. So that's 1b. Everybody had a problem just like that, but nobody had that problem. Figure that one out. Yeah.
2b.
All right. A lot of the mistakes on 2b were related to the cube dude. Everybody had a trinomial that you could not factor. Some of you guys, the trinomial didn't end up canceling with the big dude from the cube because they weren't the same, right? You just got to remember how to factor cubes. So if I had this, times like it. So everybody had a problem like this, but nobody had this problem. I don't know if you guys understand what I mean when I say that. In math, when you start to realize that a lot of problems are all the same, that's when you start to really get math. That it's the same problem. That's exactly the same problem as everybody, but nobody had that problem. So how do I do this? This is where people made the most mistakes. Little dude, big dude.
B minus
That's
5.
BBB, so that's B
Minus 5.
minus 5.
B2.
The other two B's
Yeah. Minus, plus. So,
plus
5B.
5B. The other two 5's.
Plus, yeah, 45.
What's that and that? Hey.
Exactly.
And of course, this is a nice little dude.
Minus 5.
B minus 5, B plus 5. Up here, I was getting people doing this. That doesn't make any sense because there's not 3 terms, right? And it's not a cubes or a squares, so you can't factor all. What's the only thing that you can do with this? Take out a B. GCF saves your ass. And the bottom, some people even did this, but they were trying to factor. No, that blah blah cancels with that, right? So whenever you have a cubes inside one of these problems, and you have a trinomial, you don't say how to factor it. Maybe it's going to be the big dude. Maybe it's going to cancel directly. What else cancels? You have B plus 5,
Minus 5.
B minus 5. What's the only survivor? B. Cool. So everybody can do that. Some of you guys right here, this was like a minus instead, and it did not cancel. So what? They're both still there. I don't care. They don't cancel, so they're still there. You just don't cancel them. You just write them. All right, but for this problem, it did cancel. Okay. Anything else? Homework, quiz? Yes.
Oh, so like for the denominator on 2b, like on the right side, what was that, b cubed? Like the one that canceled out right there?
The this guy?
No, the one below. We just did. On the very right. On the bottom. Yeah.
Oh, I'm sorry. So that it's the same thing that's there.
Oh, okay. So that cancels.
Why? Because it's the same as this.
Yeah.
Yeah.
Okay.
So some of you guys had a problem where that was a minus and that was a plus. So they don't cancel. You just write them again. If they don't cancel, they're still there. Right? But some of you guys had it, so those did cancel. All right. Anything else from homework, quiz? Yes.
1A.
All right, let's just...
2A, I'm sorry.
2A. Oh, all right. I was a little... somebody got this? I'm sorry. I was disappointed. So many people, and again, I know this is a human thing. You humans do some weird stuff. Let me make a problem nobody had. You could do it, Jeff. So I had way too many people doing this. Way too many people doing that. And then reducing 16 divided by 4 is 4. No, nowhere in there does it say 16 over 4. It doesn't say that at all. I know there is a 16 sitting there as part of the number on the top, but there is no 16 on the top. There is none. There isn't. I don't know what's on the top yet because I haven't broken it down into its parts yet. So I don't know what's free to die, right? I cannot break into this subtraction and addition problem. I can't break into it. I can't. I can't just decide to go, I know everything's being divided by this, but let me just maybe pretend like only this guy's being divided by that. I can't do that. So some of you guys, I started doing this and then I got tired after a lot of people were making the same mistake. I didn't write this. But if you thought you could do this, then you're telling me that you can reduce 8 over 5, for example. Can you reduce 8 over 5? No, of course not. Even though 8 is 5 plus 3, who cares? Right? So if it's addition and subtraction, the numbers that you see are not factors of the whole number. They aren't. 5 is not a factor of 8, even though you can write it as 5 plus 3, because factors are multiplied. Right? So you can't do this. It doesn't make any sense. So 8 divided by 5 equals 3. What? So 8 and 5, what operation would actually make it 3? What operation would you do with 8 and 5 to make it 3? What would you do with 8 and 5 to make it 3? Subtract, right? And why does that work? Because 8 is 5 plus 3. Subtraction is the opposite of addition. That's why they cancel. And I know some of you guys are like, Jeff, I know that shit. But it's the same thing here. Division is not the opposite of subtraction or addition. How the hell can it cancel anything? Division can't do that. But if I write the top, how do you break the top up? Yeah, n minus 2, n minus 8. Is that cool?
Yeah.
And then how do you break the bottom up?
N minus 2 plus 2.
Now division can kill parts of a multiplication problem all day long. That's what division does. That's his job. Over here, you're like, division's like, I don't know, man. I don't know. And, no, it shouldn't be able to do that. Right? Here, all day. God. And some people got to here, and then I saw this. Do you see what that person did? I'm not picking on anybody because a few people did this. Right? What did that person do?
They reduced it.
Yeah, they saw an 8 and a 2. But is there an 8? No, there isn't. There's an n minus 8.
Yeah.
And there's an n plus 2. Do they have anything the other guy has? No. This guy has an n minus 8. This guy has an n plus 2. They don't share anything. I can't reduce. So I know right now that some of you guys are sitting there saying to yourself, this is why I hate math, because you change. It used to be I could do 8 divided by 2 is 4, and now you're telling me I can't. No, math does not change. This is not 8 divided by 2. That is not what that says. This says n minus 8 divided by n plus 2. Oh shit, that is different. So of course it's not going to act the same as this. Right? Maybe. All right. Anything else from homework, quiz? Is there anything we haven't talked about in the quiz yet? Number 1A, I think. For that one, most people did okay with that. All right. So last time I did like a real quick preview of where we're headed. We're headed into section 8.1. But before I get too far away, let's do some problems from 7.6 before we get into 8.1. Let's see. Ooh, all right, we'll do that one. Let's see. All right. So there are different ways to do this problem, but I'm going to always do the way that I think is going to be the best way to do it. You can do it whatever way works best for you. So what do I do first on this problem? Yeah, this is all about LCD. And this is where the factoring comes in, because I don't know what parts this guy has. But the more you do with the homework, you're going to realize that basically these guys are this. In the real world, it doesn't always work like that, but when we're first learning, we start with the simple stuff, right? Yes, sir?
Is it possible to flip it all?
No. I appreciate because, now watch. So I like what you're thinking. You're thinking you could flip this and make it p minus 1 minus p plus 3 equals that. But what would really, if I flip this, I get this, right? Cool.
Yeah.
If I flip this side, I get this. Does that look better? So you can't flip this and this and no. You flip that side and you flip this side, right? That's the only way to make it legal. To one side, you do the same thing you do to the other side. So yeah, you can flip both sides, but that looks bad, right? That looks bad.
Yeah, I thought to make it easy.
No, it would if you could flip each piece individually, but you cannot. You flip that side, you flip that side. Ooh, shit. That does not look good. Is that cool? I don't know if anybody else was thinking about that. Not a bad thought, but no, makes it worse. So what do I do? So you guys told me this guy is p plus 3, p minus 1, right? And thankfully, of course for us, it's kind of built to do this. That's exactly what these guys are. So what's he missing? P plus 3. So you give it to him. Top to bottom is the only way to make it legal. What's this guy missing? P minus 1. What's this guy missing? Nothing. So you don't give him anything. He's got it. Right? Like, whoa, dude, I got it. So what can I do now? Why did I do that? Why did I make all the bottoms the same? So I can kill them. Exactly. So if I multiply everything by p plus 3, p minus 1, it would distribute to everything, so that dies. You die, they die, everybody dies. Except for the top. So what do I have left alive? P plus 3. Let's see if you guys do this.
Plus negative p plus 1.
Well, all right, well, so negative p plus 1. So you could pull this up there if you wanted to. Negative p plus 1 equals 1. All right, so that one fell swoop, we made the equation look a lot better. So what do I get here?
4 equals 1.
Yeah, good. 4 equals 1. Kick ass. And who remembers what that means?
No solution.
No solution. Kick ass. So that can still happen, right? The 4 equals 1 can tell you there's no solution. Or what value of p could I have gotten that would tell me no solution?
Negative or 1.
Either 1 or negative 3. There are several different ways to have no solution.
Okay. How can plus 3p minus 3 all the way at the top. The purple.
Oh, okay. So what I'm really doing there,
Because I had you and then I lost you.
you ready? So when I get all the bottoms the same, I multiply both sides by the LCD. I multiply everything by p plus 3, p minus 1. So it dies there. P plus 3, p minus 1. So it dies there. I'm multiplying both sides by that.
Okay.
I like it. That's why if I make all the bottoms the same, I can multiply by that and they all die. No fractions left. And we always want to kill every fraction we see, but you can only kill the fractions that are in equations, because then I have another side to balance me out. I like it. Cool. Sweet. Is that all right? So I wanted to do that problem just to show you. Remember, we've known this from before. Any equation that comes out 4 equals 1 or 0 equals 7, it means there's no solution. So that can still happen with this equation. Kick ass. Okay. And that's 7-6. I mean, that's basically what it is. You just got to get in there and try it out. So I really want to focus today on chapter 8. Oh, that's right. Actually, there's one more type of problem I haven't talked about yet. I'm almost hesitant to show you, because the minute I show you, you're going to try to do it everywhere, and you can't. But you guys already know about this. You've tried to use it at the wrong time. The only time you can do this process is on the kind of problem I'm going to write down right now. Right? And you're like, just do it, man. So now, let me try to attack this. Let me do this. I'm going to do this the long way, and I know a lot of you guys know the shortcut already, but I really want to make it clear that it's a shortcut, and it only works here. So let me attack this the same way we just did a second ago. What is this guy missing that he's got? 7. So let me write it again here. Let me write it again so I can... So I'm going to do it this way, and then I'm going to do it the shortcut way. So he needs a 7. Multiply top and bottom by 7, right? Okay, cool. Let me do that. Cool. And what's he need? X plus 3. And then I can multiply both sides by, so many colors.
7 times x plus 3.
Just multiply both sides by the same thing, and they die. Is everybody cool with that? But now watch. There's a shortcut now, because there was one fraction equals one fraction. You guys with me so far? This is the only time you can do cross multiplication. But students get really excited because it's simple. And then you're like, I'm going to use it everywhere. No, it's too bad for you. If it's simple, there's probably a lot of restrictions, right? So look at this. That's a 7 there, right? So it looked like the 7 just came up and went to this guy, didn't it? That's what it did. There it is, right? And what did it look like the x plus 3 did? It looks like it just came up here and sat next to the 2. So that's cross multiplication. That's the only time you're allowed to do it. There are creative ways to use the idea of it in other places, but don't try, right? Unless you're really comfortable with it. So I don't have to do all this shit. Don't have to. That explains why the shortcut works. So I can do 7 times this equals x plus 3 times 2. That's the shortcut, because that tells me it works. And then, of course, we just solve this like we always would. 28x minus 14 equals 2x plus 6. 26x equals 20. X equals 10 13. Blah, blah, blah. You guys can all do that.
I do have a question. It's in the homework. It's number 40 on 76. I was just wondering, do they through the part of the same
Oh.
denominator, and do you multiply it by 2?
Yeah, you just multiply each piece by that.
Just the one that doesn't have the same denominator, right?
Oh, well, you give it that, and then you multiply everything by that. So let's do that. This one looks a little weird, just because it looks too easy. And actually, there's something you do in the first place, because they're on the same side there. So there's 2 different ways to do this problem, but hopefully most of you guys would realize that 2 over t minus 5 minus 5 over t minus 5, I can put those together, right? So what do you get?
Negative 3 over 2 double.
And then what can I do?
Cross multiply.
Yeah, you could cross multiply, sure. So I get 1 times negative 3 is negative 3 equals 3 times t minus 5 is 3t minus 15. Is that cool? And then you're there. I like it. So that would just look weird because it was too easy. You're like, wait a minute. The bottoms are all the same already, except for that one guy. So from the beginning, the other way to do this is you could have given this guy a t minus 5, right? Because he's missing it. Kill all of these, but then what's 2 minus 5? Negative 3. And 3t, there it is, right? Both ways get you to the same place, of course. All right, math doesn't care which way you do it as long as it's a legal way. A legal way. All right, cool. So let's get into chapter 8. For reals. So there's two main things we got to talk about with chapter 8 to start with. And that is the idea of function and then function notation. Oh yes, that sounds awesome, Jeff. Sounds like a trip to the dentist. So, anytime math people call a group of things a name, there's actually a reason for it, right? Just like botanists doing their thing, biologists. So a function, let me start with this. Here we go. A relation is a group of ordered pairs. Let me stop there. Remind me, what the hell is an ordered pair?
Points.
Points, like XY points. I love it. Kick ass. So a relation is more general than a function. A function is a special kind of relation. So what could be a relation then? An example would be something like, I could have the points 1, 7, 1, 5, become a 5. 2, 8, negative 1, 0. There's a relation. That's a relation. It's a relationship between X and Y somehow. Visually, a relation could look like this. There's a relation. So when X is this, Y could be this, or this, or this, or this. It's a relationship between the two. All right? If any of you ever played with the spirograph games, there's actually a level of math where you learn the functions behind those spirographs you make. All right? Let's come back. So what the hell is a function? A function is a special kind of relation. And one of the, this is not, screw it, this is true enough. Let me just say that. This is true enough. It's just a beautiful way to look at it. The problem with both of these, could this be, if I was standing here somewhere and I threw a ball, could this be time versus position? Because what would that mean? That would mean at time 1 second, the ball was here, 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 and here. Right? Here, catch this ball. Boom! What the hell is that? You guys understand what I'm saying?
Yeah.
So I want, a relation can do anything. All you need is an X, comma, a Y. Is everybody cool with the fact that these are like the same? This is just a few points. This is a lot of points connected, right? But they're still just ordered pairs. So they're both relations. But a function, I want it to make physical sense. Let me say this again. I want a function to be able to make physical sense. So functions have to model the real world. And if I throw a ball, it's going to be in one place at one time, right? There's no samurai, chop it in half. Your ball is there and there. No. Get away from me, samurai. Stop it. Right? Pesky samurais. You Mongolians. Sorry. So, a function. Are you ready? So if I asked if I ask you, what size shoe are you wearing on your left foot? I pointed to your right foot. All right, 11, right? If I ask somebody, does somebody else wear size 11 shoes? Okay, there you go. Look at that. You guys, that's awesome. You guys talked and said, we wear size 11. Let's sit together. It's really nice. So they could certainly both wear the same size shoe, but I can't ask a person what size shoe are you wearing on your left foot, and they tell me 9 and 10. I'm like, what is happening with you? Right? Do you guys understand? The reason I'm being very specific is if I ask somebody what size shoe do they wear, their feet could be very different sizes, right? Just because they were born that way. So like 9 and 10. But if your left foot, are you wearing 2 shoes? Who are you? What's going on in your life? Right? So a function I want for every input. So that question was like an input. You're an input, you're an input. And in this case, so an example would be, the input would be people. And the output would be size shoe on left foot. All right, let me stop there for a second. So some of you guys know where I'm going with this. Some of you guys are like, I don't know, we're talking about feet now and shoes. So everybody in here would be an input. And each person would be able to tell me an output. You can tell me what size shoe you're wearing. I don't see any barefoot people. Okay. Even then it would be size 0 because it doesn't exist. Right? So a function can't do this. So if I ask a person what size shoe, if I ask this person what size shoe are you wearing, and they tell me this size, this size, this size, and this size, it doesn't make any physical sense, right? So a relationship can do anything it wants to be. Every input, look how 1 has 2 outputs here, right? Do you see that? 1 has a 7, 1 has a size 7. He's saying, you, what size shoe? And you say a size 7 and a size 5. That's still freaky, right? Or I say 1 second later, where's the ball? 7 feet up in the air and 5 feet up in the air. What happened to that ball? What's going on? What kind of game is this? Maybe. So here's the definition of function. You ready? And if you watch Highlander, I love it because it actually fits into the definition. Have you ever seen Highlander? Movies or TV? All right, you ready? Somehow it works in there. A function is a relation between x and y where for every x, for every input, make an n in there, Jeff. There you go. For every input, for every person, for example, for every person I ask the question, for every dog that I see how much they eat, for every this, see what they bet, right? For every input, for every x, there can be only one output. Let me stop there for a second. So it makes physical sense, right? If you start walking and I ask you, 5 minutes later, where are you? And you tell me 3 miles that way and 7 miles that way. I'm like, teach me. I don't need to be in several places at once. How did you do that shit? Right? So to make physical sense, for a question, there must be one answer. But if you both start walking, is it okay that you both are 5 miles away?
Yeah.
So much, whatever many hours later. So what do I mean with that? So here's an example of a function. This is an example of a function. That is a function because are there any inputs? And which part of those are the inputs? Which part of the points are the inputs? The x part. So these are inputs here. Are there any inputs that have more than one output? So what output is there for an input of 1? What output for 2? What output for 3? So each input has only one output. Does it matter that these both have the same output? No. It's like, does it matter that 2 people have the same size shoe? No. That makes physical sense. But one person can have 2 different size shoes on their left foot. Right? But let's just, no, it doesn't happen. Right. Tomorrow somebody's going to come in, look, Mr. Wall. Jeez. That would be funny, actually. I'd like that. So let me see. So that is a function. Can somebody help me out? How would I make something that's not a function? It's not a function. Let me start us off. 7, 2. What can I put there so that it's not a function?
7, 4.
7, 4. Kick ass. I like it. Because now if I'm asking person number 7, what size shoe? And they say, well, 2 is really small. Person number 7, how far did you walk? 2 miles and 4 miles. What? You walked one of those. Do you understand? Okay, good. Somebody's like, yes, man. Move on. Okay. What does this mean visually then? Graphically, what does this mean? Lazy teacher showing a movie. So graphically, what does this mean? So let's think about it. If I want to graph something, for every x, there can be only one y. So what can't happen? So if I start, what can I not do? So far it's good, right? Every x, this x has that y, this x has that y. So what can't happen? It can't come back on itself, right? So everything's good so far until it does that. That is not a function. It's not a function. It's not a 2. Why exactly? Because, tell me why exactly. How does that relate to the definition of function? Is there an x that has more than one y? Yes. So all the x's here have more than one y. So a quick test. Who knows the name of this test? The test for a function. I don't know if anybody's gone that far.
Oh, the vertical line.
Vertical line test. And why does it make sense? A vertical line represents this x value, doesn't it? That x value, it's the same. X equals 7. It's a vertical line. Do you remember learning that? It's a special case. So if I draw a vertical line, that represents an x value. If it goes through the function if it goes through the graph more than once, it's not a function. Because that would mean that x value has more than one output, more than one y value. Does that make sense? So the definition is for every x there can be only one y. Visually, that means this. A vertical line cannot go through more than once. All right, so this is not a function. To be a function, a vertical line can't go through more than once anywhere. All right.
Other exception?
No. You start to learn more about different ways to look at. So, for example, let me show you. I don't want to get too far away from this. Let me give you a picture. Is this a function? What, Jeff? I don't know. Hold on. Is that a function? No, it's not. It's not a function. Why?
Because it has more.
Yeah, if I draw a vertical line, there are vertical lines that go through more than once. All you need is one line that doesn't work. One vertical line that goes through more than once. That's all you need. Now let me just say this real quick. That's looking at it from the x point of view. If I look at it from the y point of view, that is a function. That's as much as I'll say. So later you start realizing how flexible x and y axes are, right? We don't know it yet. So let's come back. We're not going to go there. Don't freak out. Right now we're always talking about x is the input, y is the output. So that is officially not a function because I can draw a vertical line that goes through more than once. Kick ass. All right. I like it. I like it. So let's move on to this here. Let's move on to. Let me write up here a function. So this is a function. Okay. So why is that a function? Because
There's only one input for every.
yeah, for every input, there's only one output. I like it. Right? 4 and 6 share the same output, but who cares? That's like you guys wearing the same size shoe. Right? So the domain is just a special name for the collection of all x values that I'm allowed to use. So can you just tell me what's the domain of this function? So this is a function, check. Check. What's the domain of this function? What x values are allowed to be used?
4, -7.
Yeah, it's crazy. They're staring in the face. So the domain is 4, -7, and 6. So the domain is the collection of all the x values you're allowed to use. Why am I not allowed to use 5? Because the function doesn't tell me what happens when x is 5. So I'm not allowed to use it. It's undefined for x equals 5 because it doesn't define what it does. So this is a collection of all the x values. The range is probably going to be,
Collection of all Y.
that's crazy, collection of all the y values. So what's the range of this? Kick ass. I like that, Jackson. It doesn't make any sense to say 225, right? It's like saying, what kind of money do you got? I got 1 penny, and another penny, and another. You got a bunch of pennies. Jeez, just say it once. So the range of this is 2 and 5. That's the numbers that it can have as an output. How are we doing so far? Not a big deal for 225, but just don't. Doesn't make any sense. We're doing okay so far? I mean, you guys should have probably talked about domain and range at some point. So now, the same thing we did earlier. I started with sets, and then I went to graphically. So let's talk about domain and range graphically. In full graphic detail. So let's see this function here. All right, there's a function. That's a nice looking function. Why is it a function? Because you said so.
Because it hits points one at a time, and you can pass the vertical line test, and like points won't hit the line.
Good, so you can draw no vertical line goes through it more than once. Cool. I like it. So far so good. The domain, what would the domain, what's the domain?
-1 and 3.
And how do I write that as a, why did I have to write it like this over here? Because it was 4, -7, it was finite. It was only those 3 points, right? How do I have to write the domain here? It's everything from -1. Can everybody see that? That's where the domain starts. It's almost silly. Is there any x values below that actually have an output? No. Am I allowed to use -2? No, it's not defined, right? So I kind of always say, have a little dude walking on the x-axis, and the first place he sees it is the start of the domain. What's the last place the little dude would see it? 3. So the domain goes from -1 to 3. Interval notation. Interval notation means everything between those two, right? And there's no open circles on this graph.
Would you be wrong putting it 3, -1?
Yes. You always put smallest, comma, biggest. From this to that. Kick ass. So just don't do that. What about the range? What do you think I do for the range?
-2, right? 3.
Not -2. Nothing has an output of -2. Little dude walking on the y-axis sees it first at -1, and he sees it last at 3. All right, good job, Jeff. I didn't mean to make it, but it's not always going to be the same, right? Don't take that away from this example. It just happens to be the same here. I like it. You guys kind of with me so far? Don't let that be a problem. Domain, x's. Range, y's. I like it. All right. All right. One more idea to talk about, and then I got a little group worksheet thing for you guys to work on. And this, for some reason, this freaks people the hell out. So let me try something, a different approach here. In English, I can say this. My function doubles an input and then adds 1. My function doubles an input and then adds 1. How do you write that in mathematics? So math people would cringe and go, man, there's so many freaking words. Can we condense that shit? Right? So how would I write this as a mathematical statement. So whatever so let me say, this is function notation. My function takes something and it does what to it? It doubles the input. Whatever this is, whatever the input is going to double it. So how do I write, so if it's x, if I'm using x, how would I write this in math?
2x.
Yeah, doubles the input, 2x plus 1. So what if somebody else is like, no, I don't want to use x, I want to use y. What would it do to y?
2x plus 1.
No, it's not 2x plus 1, it's 2y. It takes whatever your input is and does that to it. Let me stop here for a second. So this is what's new, this notation right here. And all it is, the notation, I'll show you why it exists. But for one thing, I can always see my input. And I can name functions different things. I can have the f function, the g function, the c function for cost, the r function for revenue, the w function for number of watermelons, whatever, right? So I have a lot more, instead of just everything's y. Y equals that, y equals that. Which one's the watermelon equation? Shit, right? I hate when that happens. So what would f of 4 be?
2 times 4 plus 1.
Yeah, 2 is always twice the input plus 1. Twice the input plus 1. So twice the input plus 1.
A plus 1.
A plus 1? 9. So f of 4 equals 9. Can somebody tell me what point that represents? What point does this function go through? What point does this function go through?
4, 9.
Yes, so that's one little tiny reason why we have function notation. So I can see my input and my output all on one line. It goes to the point 4, 9. Input 4, output 9. Kick ass. All right, that's one thing. All right, how are we doing so far? What I always get somebody that does, this is a mistake. Don't even write this down. So pick your pencils up. I always get somebody that does this. F equals 9/4. And I understand somebody goes like, what's wrong with that, dude? This is F times 4. No, it's F at 4. F of 4. The function evaluated at 4. Right? So this is not what we're used to. This is not like 4x. This means the function doing this to 4. So I can't divide by 4. It's not multiplied by 4. Maybe. So let's do this. Last little thing before I give you this group worksheet here. So if I said f of x, let's do a different f of x, right? F of x is 3 minus x. G of x is x squared plus 2. And h of x is x over x minus 1. So now I can have several functions, and when I ask you this question, it's really weird to me that just tell me why. Well, help me out here. Let's see. If I ask you what is h of 3, which function are you going to use? The h function, because it says freaking h. But I always have somebody put 3 in all of these. They're like, let me just cover my ass. One of these is right. Jeff don't like that. Right. So h of 3 would be 3 over 3 minus 1, 3 over 2. Kick ass. So what this notation means is replace x with 3 in the h function. That's all it means. It's just substitution. That's all function notation itself really immediately is. So what is g of negative 4?
4 squared plus 2.
18. So when you plug negative 4 in, you got to square the whole negative 4. The big mistake there is people square 4 and leave the negative. Negative 4 squared is positive 16, right? All right, here's the last one of these. What is f of w?
3 minus w.
3 minus w. Don't make a big deal out of it, right? F of w is 3 minus w. You just replace x with whatever's in there, and put a w in there. All right, let me finally shut the hell up. Are you still going? Yeah.